Hi students, this is the question of the JEE Advanced 2024, question number 9 in the paper 1. I did solve this question, but at that time I did assume that this axis is actually the fixed axis. But then I did analyze this question again and I did see the other solutions. So from that I understood, okay, actually this axis is not the fixed axis. This axis is actually the fixed axis. Now you can look this animation. In this animation I have given the actual rotation. This is how it will rotate. So this is the red one is the bigger disk, and the bigger disk z-axis is the fix, and there is this white motor that is attached to the disk. It is fixed, and there is the shaft of this disk. So in the animation I have drawn it with the white cylinder, and then there is this dark blue disk which is a smaller disk. Now what happens when the motor starts rotating, as you can see in this animation, so that what will happen, that shaft of the motor will rotate, and because of that this blue disk will start rotating. But because if you look from the point of the z-axis of the fixed axis, there is the total torque on the system is 0. That's why the net angular momentum should remain conserved about that point, about that z-axis, and that's why this bigger disk will start rotating in the opposite direction, as you can see in the animation. Alright, so how do I solve this? So look, here you can see this is the same diagram. Here is our bigger disk, this one, and this is the bigger disk axis of rotation. So we know that the total torque about z-axis, and when I say z-axis, this one is the z-axis. Alright, z-axis is tau net equals to 0. So it means that the angular momentum L should be conserved. So what was the initial angular momentum? 0. So it should remain 0. Okay, now let us write down the angular momentum. So we know that this blue disk over here, I have taken the bigger disk as blue. So it will start rotating with some omega dash, right? Let's suppose it is rotating. When we look from the top in our animation, it is rotating in the anti-clockwise direction. Okay, so let us take omega dash anti-clockwise as positive. So then can I say that the I of the bigger disk multiplied by omega dash, this is the angular momentum of the bigger disk. Now let us also write down the angular momentum of the smaller disk. So a smaller disk is rotating, as you can see in the animation, this dark blue disk is rotating in the clockwise direction. So the angular momentum, as you know, of any body is written down as ICM omega plus m r vector cross VCM vector, right? Okay, so we know that the ICM will be, let us keep it I, smaller disk about the center of mass, multiplied by omega. Omega is omega, but that is in opposite direction. That's why I need to put the minus sign. Alright, because if you look from the top, it is rotating, this disk about its own axis is rotating in the clockwise direction. Okay, and then we have the positive term, that is m mass of this smaller disk multiplied by v r vector cross VCM is equals to 0. Now look, the velocity of the center of mass of the smaller disk will be simply omega multiplied by r. Alright, and it will be in the same direction in the sense of the rotation of the omega dash, right? Omega dash multiplied by r. Alright, where r is the radius of the bigger disk. So let me put it. So then we have half, we know that the bigger disk radius is r, so mr square multiplied by omega dash. Let me also write down this term. So then this term is m multiplied by r of the bigger disk, because the position vector of the center of mass, this perpendicular distance between the center of mass of the this disk and the axis of rotation is r only, and the VCM is omega dash multiplied by r. And here I am writing down the positive sign, because if you do the cross product from the from the right hand thumb rule, you will get the same direction of the omega dash. Okay, and then minus, now I of smaller disk, look, I of smaller disk is half mass of the disk is m, and r by 2, the radius is r by 2 for a smaller disk, multiplied by omega is equals to 0 omega, right? So here we have 3 by 2 m r square omega dash is equals to, and now it will become 1 by 8 m r square omega. Now the m r square will be cancelled out, then we are getting the omega dash as omega by 12. So the omega dash will be omega by 12, and in the question they have asked us what is the value of the n if the omega dash is omega by n. So n value will be 12.